Hello, welcome to my video on data structures. This is part 3 for the queue and stack data structure. In this video, we will talk about the implementations of stack. As we have discussed in the previous video, the implementation of stack is very easy. The stack data structure can use vector as its internal storage. Therefore, we can implement stack by simply reusing some functions from the vector data structure. The top operation for stack returns the data element that is the most recently added. In this case, the data element should locate at the last position of the array. And we can implement the top operation in the same way as the back operation in vector, where both of them return the last data element in the array. Similarly, for the push function, we are trying to add a data element to the end of the array. It is therefore identical to the pushback operation of vector. Finally, for the pop operation, it removes the last data element from the array and is identical to the popback function of vector. The private members of stack is also the same as the vector. We have an array items that stores the data elements, a scalar variable, the size, that records the number of stored data elements, and another scalar variable, the capacity, that records the maximum number of data elements that can be stored in the stack. Now, let's briefly go over the test program. We have a file that stores a set of numbers, one number a line, as shown on the right of the slide. We read in the numbers and store in the vector called data. We then write a while loop to process each element in the data vector. As line 2 shows, we defined a random variable to insert, which is the remainder of 2 for some random integers. In this case, there is a 50% chance that we would insert the current variable to the stack, and another 50% chance that pops an existing element from the stack. Note that the data element is not consumed if we choose to pop an element. As line 12 shows, we also issue a warning if we are trying to pop data from an empty stack. After each operation, we print out the snapshot of the stack, showing the most recently added data element, the size, and the capacity of the stack. Now, let's take a look at the output of the test program. The first operation is pop. As expected, the program issued a warning as there is currently no data in the stack. The subsequent 3 operations are insertions. We can see that the top data elements and the sizes are updated accordingly, and it meets our expectation of the stack behavior. We also see that the capacity of the stack is increased to 6, which is twice of the size after the current insertion. The next deletion removes the most recently added data element 3, and we can see that the top element in the stack becomes 2 after the deletion. You can take a look at the remaining output of the test program and verify that it meets our expectation of the stack behavior. In summary, in this video, we discussed the implementation of the stack data structure, and we have tested our implementation. In the next video, we will discuss the implementation of queue. Thanks for watching and see you next time.